Okay, so we learned about two rules of consequence, which were essentially the following. One was um, the simple rules of inference, P, S, R, P, S, R, comma, R implies Q, then we can conclude that P P S Q. And there was another one, the P, this is A, and this is B. Okay, and what did we say? The other one was if P implies R and R is known to be the precondition for a program S results in the postcondition Q, then we can conclude that P S Q. And these rules are called the rules of consequence. Okay. Now let us look at let's look at some specific forms. Let's look at some specific forms of P and Q. Okay, where we know S. Okay, a null statement, which is a simple semicolon in C, or in pseudocode, I'm just going to write it as P skip P. Then that means what? P is the precondition and P is also the postcondition for the null statement. Now let's look at an assignment statement. Or an assignment statement. Let's look at a simple assignment statement. How does an assignment statement look like? It is like a variable which is assigned an expression, okay, on the right hand side. And what can you say about an expression, if I write it formally, is expression add operator term, so this form, or term and add operator is either plus or minus, and term is, I'm just writing it grammatically so that you know what I mean. Term multop factor and multops. Let's say if you're writing it in C, it's star slash percentage, and factor is essentially a variable name or a number. Okay, so this is where I'm coming from. All right. So what we're saying is on the left hand side, this is an expression. So when you're looking at variable equals expression, sorry, it should be an equals over here. variable equals expression. So what is that we are saying is a variable is defined in the program and that is equal to an expression. An expression consists of terms, is a sum of terms, and a term is actually a product of factors. And the factors can be numbers or it can even be another variable. So what we are looking at is how do we write this in. So basically what do we want now? I have a variable, let's say int x, I'm taking integer just for convenience over here. And let us say I want to assign an expression e. Let's say e is an expression here. And I want to assign this expression to the variable x. Then basically it sets x to e. Now we write the precondition as PEX, the precondition before the expression was executed, and x is assigned the value of the expression, and E, I'll tell you what this notation means. P is true. What this means is, over here is P is true for E before the assignment is made. Okay. Then P is must be true when X is assigned E. That is, P is true for this expression, then the truth of the expression remains the same before and after the assignment. Okay. So what does this mean? Let's take an example over here. Let's say before a program is executed, I can assign, let's say this is what x plus y equal to 10 is my assertion. Now, and let me call this the expression. Okay. Now I'm putting z is equal to x plus y, where x plus y is my expression. Then, sorry, x plus y is equal to 10, let us say here. So this is my expression. Okay. So what does it say here? It says that the expression evaluates to 10. That is the assertion. We can assert that the value of the expression is equal to 10 before the execution of this statement. Now what we're doing is we're assigning to z the value of x plus y. Then we can assert here z equal to 10, which is essentially saying the truth value of the expression is nothing but 10. Okay. Basically what this means is P is true for x plus y even before the assignment to z is made. Okay. This is what this means. And let me take another example. A little more, this is a little subtle. Let's take another example. Let's say I have x minus y greater than or equal to 0, and is the assertion that I can make. Now, what can we assert about x? x is assigned the value of x minus y. Now we can assert that x is greater than or equal to. Okay. So notice that here itself we could have asserted that x has to be greater than or equal to 0. And so the assertion P does not change whether the assignment statement is executed or not. So this is a truth about expressions. Let me take one more example. Let's say we start out with this assertion m less than or equal to n plus 1, m plus, less than or equal to m plus n over 2 less than or equal to n. Now I assign m plus n by 2, then what can we assert about x? M less than or equal to x less than or equal to n. And this remains true whether for the expression, whether we execute the assignment statement or not. Okay. The next rule that we're going to talk about are what we call compound statements. Let us see what a compound statement is. So what we right now saw was in the assignment statement, the truth value that an expression takes does not change. An expression is assigned to a variable. Before the assignment to the variable, the expression has a particular truth, and that truth remains valid even after the assignment is made. That's what we have seen. Now, this is a very important property for us because this will enable us to prove composition of statements or work with compound statements. Okay. What is a compound statement here? Where we assume sequential or serial composition. Okay. And we have a statement S1, S2 up to Sn, which are executed. Okay. Now, an example would be something like this. I can use assignment itself. X is assigned the value of x plus 1, assuming that variables have been declared appropriately. X plus 2, y is equal to x plus z. So each one of these, for example, there is a particular precondition for this, and there's a postcondition, precondition, postcondition. Let's say P1, Q1, and Q1, Q2, and we have Q3 becomes precondition for Q4 or for Q. So basically what we're saying is P1 and S1, Sn should lead us to Q. This is what the rule of composition is. Okay. So taking two statements for that matter, let us say we have P precondition S R comma R S1R R S2 Q, then we can conclude P S1 S2 R. Okay. Again, let us take this example here. This is a very nice example where we combine the consequence rules. X is equal to y star 1 plus q plus r minus y. Was the precondition. And then we assigned r equal to r minus y. Then we got x is equal to y star 1 plus q plus r as the postcondition. Now we start with this. X is equal to y star 1 plus q plus r, and then now suppose I make this assignment, q is equal to q plus 1, then what do we get? We get x is equal to y star q plus r. We can generalize this. So that means what do we do? We started out with this precondition. We executed this statement and also this statement, and this led us to this assertion. This is P here and this is Q here. So we can generalize this rule of composition and say P of I minus 1 Si Pi I equal to 1, 2, n. We can conclude P naught S1, S2 up to Sn will lead us to P. So this is the rule of composition, and I guess we can stop here for the day and take some questions.